Here, let us perform an activity to know the effect of temperature on change of state. Click each tab to know more. Take a beaker filled with small ice cubes. Insert a thermometer into the cubes. Observe the thermometer reading. Now put the beaker with ice cubes on a burner with help of tripod stand and start heating the beaker. Then the ice cubes start melting. Observe the changes in the thermometer reading for every 1 minute until all the ice melts. In this activity, we observe that the temperature of the mixture of solid ice and liquid water does not change for some time. It changes only when it reaches specific temperature. The temperature starts changing only when ice completely melts. Finally, we learn that at a certain temperature, the solid melts and changes into liquid. The temperature at which a solid melts to become a liquid is called melting point. The process of changing a solid to liquid is known as fusion. Here, let us perform an activity to know the effect of temperature on change of state. Click each tab to know more. Take a beaker and pour some water in it. Place it on the burner with the help of tripod stand. Measure the temperature of water with the help of thermometer and note down the readings for every 2 minutes. Observe that the temperature of the water increases continuously till it reaches 100 degrees Celsius. In this activity, we observe that the water boils to steam when the temperature reaches 100 degrees centigrade. This shows that the particles in water vapor at 100 degrees centigrade have more energy than the particles in liquid water at the same temperature. Finally, we learned that at a certain temperature, the particles have enough energy to become free from the forces of attraction among the particles and the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling point of water is 100 degrees centigrade. Let us know some important definitions. The following tabs give the information about the latent heat of fusion, latent heat of vaporization, and anomalous expansion of water. Click each tab to know more. Heat required to convert 1 gram of solid, that is ice, completely into liquid at a constant temperature is called latent heat of fusion. Consider a solid of mass, that is m, which converts from the solid phase to liquid phase when heat, that is Q, is supplied to it. The heat required to convert gram of solid into liquid is Q by m. Latent heat of fusion L is equal to Q by m. The value of latent heat of fusion of ice is 80 calorie per gram. Heat required to change 1 gram of liquid, that is water, to gas at constant temperature is called latent heat of vaporization. Assume a liquid of mass as m requires heat Q calories to convert its state phase of liquid to phase of gas. Then latent heat of vaporization is given by the expression Q by m and is denoted as L. SI unit and CGS unit of latent heat of vaporization is joule per kilogram and calorie per gram respectively. A liquid usually expands when it is heated, but water behaves differently. Between 0 degrees centigrade to 4 degrees centigrade, its volume shrinks. Same amount of water in solid ice occupies more volume than liquid water. We say that water expands, increases in volume on freezing from 4 degrees centigrade to 0 degrees centigrade. This is an anomalous expansion of water. The density of ice is less than that of water, and this explains why ice floats on water. Effects of change of pressure on matter. We know that water exists in 3 different states, namely solid, liquid and gas, which are otherwise known as ice, water and vapor. Top of high mountains and Arctic and Antarctic oceans have water in the form of ice, that is, snow. Oceans, rivers and lakes have water in the liquid form. The vapor form of water is present in the atmosphere. Steam is observed when water is boiled. We also make ice using the special section given in the refrigerators called freezer. It is important to note that the 3 states of water are interchangeable. When water is boiled, steam is observed. On the other hand, when steam, that is gas, is cooled, water, that is liquid, is obtained. On heating, ice, that is solid, changes into water, that is liquid. If water, that is liquid, is cooled below 0 degrees centigrade, we get ice, that is solid. Similarly, solid carbon dioxide converts directly into gaseous state when the pressure is decreased to 1 atmosphere. Due to this reason, solid carbon dioxide is also known as dry ice. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid or gas. Here, let us perform an activity to know the effect of wind speed on evaporation. Click each tab to know more. Take a small amount of spirit in a cup. Pour a few drops on your palm. Observe the changes. Once again, take a few drops of spirit, say 1 ml, and pour the drops into 2 petri dishes individually. Generally, the petri dishes are shallow glass or plastic cylindrical lidded dishes used in the laboratory. Place both the dishes under a ceiling fan and switch it on. Close the lid of one dish. After 5 minutes, check the quantity of spirit in both the dishes. In this activity, we observe that the spirit disappears in the dish kept under the ceiling fan. At the same time, some quantity of spirit can be found in the dish which is closed. Finally, we learned that evaporation is a surface phenomena. During evaporation process, the particles escape from the surface of liquid. The increase in the surface area provides more scope for particles to escape from the surface, and this increases the rate of evaporation. The phenomena of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Humidity is another factor that affects evaporation. The amount of water present in air is called humidity. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water vapor is high in air, the rate of evaporation will decrease. So clothes dry slowly during rainy season but fast on a sunny and windy day. Because of increase in wind speed, water vapor particles move away with the wind, decreasing the amount of water vapor in the surroundings. When we work, the body produces heat. This increases the temperature of the skin. As a result, water presents in the sweat glands. The particles of liquid absorbs energy required for evaporation from our body and escape to the surroundings. This makes us to feel cool.
Knowledge check. Attempt the following questions to check your understanding. Keywords. List of keywords are shown on the screen. Summary. Let us recap the highlights of the
But do not have a definite shape. Gases have neither a definite shape nor a definite volume. The force of attraction between the particles is maximum in solids, intermediate in liquids, and minimum in gases. The particles are arranged. Phenomena of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Humidity is another factor that affects evaporation. The amount of water present in air is called humidity.
Read the questions and attempt the answers on your own. You can click Answer for your reference.
Follow-up work. Prepare a model to demonstrate movement of particles in solids, liquids, and gases. Suggest an activity which provides the evidence for the motion of particles, attraction between particles, and interparticle space.
Test your understanding of the chapter by taking the mock unit test.
You have successfully completed the chapter Matter